Welcome back. Let's look at a carboxylic example that's a little bit more complicated, and let's put some very basic branches in there. So I'm going to start off with a carboxylic acid, which I'm going to give it 5 carbon atoms, right? I'm going to make sure it's an acid, so I've got my carbon double bond O bonded to oxygen bonded to hydrogen, and then I've got all my in-betweeners over there. Okay, I'm going to place that over there. Like so. Okay, and then also let's just put one over here, and then we'll identify which is our longest chain, and then we'll get on with naming this baby over here. Okay. Okay, so it's always good practice for you to write this down with me, because I don't want you to do physics as a spectator sport, right? You shouldn't be watching me, because then that's me doing it. You need to do it. You writing the examinations, I hope. Okay, so let's find the longest chain. If I count from here, I got 1, 2, 3, 4. Okay, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, but I've got the carboxyl functional group on this side, so I need to actually number closest to that. 1, 2, 3, 4, 5. So that could be my longest chain. 1, 2, 3, 4, 5. That could be my longest chain. 1, 2, 3, 4, 5. That could also be my longest chain. So definitely the longest chain contains 5 carbons, because this thing over here contains 5, that thing over there contains 5, and also the thing straight across contains 5. You could choose any one of the 3 really, as long as you start counting from closest to the functional group on this side. I'm going to make that number 1. I'm going to go straight across because it's a bit easier than working around the corner with things over here. And let's see how we do that. Okay, so we've counted across and we've gone there 1, 2, 3, 4, 5. Let's see. Okay, that means that everything here besides that is going to be what we call side chains, right? So we've got that one over there as a side chain. We've got this one over here as a side chain. And we've got that one over there as a side chain. Well, we've numbered closest to the functional group, and as you've identified, this is Cu. What is Cu all about? It's an oic acid. It's a carboxylic acid, right? And the name ends with oic acid. So we start with the main chain, and we can see there are 5 carbons, so let's name that. 1, 2, 3, 4, 5. That's going to be pent. Single bonds between my carbon atoms, and that's pentan. And I see it's got Cu, so it needs to be an oic acid. And similarly, I've got these side chains. So I've accounted for the main chain, I've accounted for the functional group, the main functional group over here. And then I've got these 2 side chains. Well, this side chain over here is an ethyl side chain, right? And this one over here is a methyl side chain, and so is that one over there. So there are 2 methyl side chains. Right. And what I now need to add is, I need to do it in alphabetical order according to the side chain. So ethyl will come first and then methyl. And I need to indicate where the ethyl lies. So the name would be 3-ethyl dash. Where does the methyls lie? There's 3 and 4. So 3, 4 dash. I'm just going to put this up in here. Dimethyl, because there's 2 of the same. Dash, no dash, 3-ethyl dash 3, 4 dash dimethyl pentanoic acid. We look at it in alphabetical order. Ethyl comes first, so the E goes first, and methyl comes second because M comes after E. We don't worry about di, tri, and tetra when we look at specifically the alphabetical order, right? And so that's that molecule over there, 3-ethyl dash 3, 4 dash dimethyl pentanoic acid. Okay, let's do one more. Okay, let's try something. 1, 2, 3, 4. Double bond oxygen there, bonded to O, bonded to H. That gives me my Cu. I'll put this over here. I'll put that over there. Hydrogens on all of these. 4 bonds around every carbon. Those are covalent bonds. Okay, and so hydrogens, right. Okay, there we have it. We have it now. We have it. And remember, we're going to number closest to the functional group whilst also finding the main chain, which has to be the longest chain. If I start in this one and I go there, I will see that I've got 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. Okay, great. The one that goes across, usually check that one first. It could be the longest or it could not. In this case, it definitely is the longest. And that gives us the following as side chains. That's going to be, this is a side chain, that is a side chain. They definitely contain 1 carbon each, CH3 side chains, and that's going to be methyl side side chains. Okay, and so let's name that baby. 1, 2, 3, 4 carbons. 4 carbons is bute. Single bonds between our carbons gives us butane, and the carboxylic acid part over here, which is Cu, tells us it's an oic acid. It's a carboxylic acid, so the suffix or the name that ends in it must be oic acid. Remember, the functional group is not called a carboxylic acid, but it's rather called a carboxyl functional group. Okay, so that's butanoic acid. Right, let's look at the side chains. Well, it's methyl side chains, so you need to put down methyl. And there are 2 of them, so 2 of the same according to our summary sheet says di. And well, you need to tell us where they occur. It's 2, 2, which means they are on the second carbon. Both of them dash dimethyl. 2, 2 dash dimethyl butanoic acid.